Hi, year 13s. I'm going to show you how to do one of the homework questions. So it's a bit tiny. This is homework question 7. Find dy by dx in each of the following 3 cases. It's a bit tiny. So here are the 3 examples. There we go, 3 questions. So let's look at the first one. So what we're going to decide first of all is what rules are going to help us differentiate this. So we have a look at this. We can't simplify that, okay? We have got 2 functions of x next to each other. So what we have here is we have a product, okay? So 2 things next to each other, so that one is the product rule, okay? And so we would use, say, u is x cubed and v is e to the 2x, okay? Let's look at the next one. So again, we can't simplify this log because it's not just 3 times 2x squared. If there's an addition there or subtraction, you can't simplify that log using log rules. Okay, and we don't have 2 things times together because it's natural log of this bracket, not natural log on its own times the bracket, because natural log on its own doesn't exist. It's natural log of something. So that means we have got natural log of another function. So a function in a function, composite functions, that has got to be the chain rule. So we would take this bit inside the brackets to be u, okay, and this is the chain rule. Okay, and then finally, if we look at the last one, there's nothing that would factorize and simplify top and bottom there, okay, and so instead we see we've got a fraction, there's some x's on the top and some x's on the bottom, so that means we have got a quotient, so we'd use the quotient rule. Okay, so if you see a fraction, the most likely thing is the quotient rule. So the numerator is u and the denominator is v. So we've got u is going to be x and v is 2x plus 1. Okay, so let's have a little go at those. So for the first one, remember we just differentiate each part. So du dx is going to be 3x squared. dv by dx, okay, now you can use the chain rule for this, but it's one that you should have memorized from year 12. So e to the kx becomes ke to the kx. So this is 2 e to the 2x. Okay, now the product rule you do not get given, but the formula is to get dy by dx, you do v du by dx plus u dv by dx. It's like the numerator of the quotient rule, except this is a plus. Okay, so let's pop everything in the right place. So we have dy by dx is equal to, so v is e to the 2x, and du by dx is 3x squared plus, and then u is x cubed, and dv by dx is 2e to the 2x. So then we do need to tidy slightly to put the numbers at the front. So I'll write 3x squared e to the 2x plus 2x cubed e to the 2x. And just stop there, because the question just says, you can hardly see it, find dy by dx in each of these cases. It doesn't say simplify. So don't waste your time, because you'll need as much time as you can get in your A-level exam. Right, let's have a look at the middle one with the chain rule. So remember, we can write y is a function of u, so natural log of u, where u is 3 plus 2x squared. Okay, so let's differentiate with respect to whatever letter we've got. So dy with respect to u becomes 1 over u, and then du by dx becomes 4x. And the chain rule is the easy peasy one. Okay, so the chain rule is dy by dx is dy by the other letter u times du by dx. Now you need to be super duper careful that when you have a product, you don't just differentiate those two and multiply them together. That does not work. So do not mix up the product rule with the chain rule. So the product rule deals with the product, but in its formula, you've got this addition thing here. Okay, whereas the chain rule deals with composite functions, functions of functions, excuse me, and you end up with the product of derivatives. Okay, so let's substitute in. So we've got dy by dx is going to be 1 over u, and let's see what was u. U is 3 plus 2x squared, okay, times by du by dx, and so we simplify that just by writing it as a single fraction. Okay, excuse me. Let's have a look at the very last one. So it's a fraction, it's the quotient rule, and this one you get given on your formula sheet. And we know that for part of it, we're going to need to differentiate. So first, I'm going to differentiate each of these with respect to x. I'm really hoping you're fine with those ones. They're nice. Okay, so we've got dy by dx is equal to v du by dx plus u dv by dx over v squared. Oh, sorry, minus, I must remember that. So that will be given to you on your formula sheet. So you can look that one up. Happy days. Right, let's just substitute in everything in the right places. So dy by dx is going to equal, so v is 2x plus 1 times du by dx, which is just 1, minus u is x times dv by dx, which is 2. And this is all over v squared. Okay, so then we do a bit of a tidy there. So what have we got? We've got 2x plus 1, take away 2x. 2x plus 1 minus 2x over 2x plus 1 all squared. And, oh, can't quite see that. And so let's just do the subtraction at the top. So we get 1 over 2x plus 1 all squared. So notice I did not expand the denominator. There's absolutely no need to. But when you've got some simple algebra in the numerator, you will be expected to expand and simplify that. Okay? You, as long as this was in a respectable state, so maybe if you had the 2 at the beginning, you could probably leave it. Okay? I hope that helps.